Yeah, you welcome to Olusegun Mass Clinic. Today we are doing commutative property. And what do you understand by commutative property? But before we start this lecture, don't forget to subscribe to Olusegun Mass Clinic and follow us in our Facebook page and try to share this video. Now, in commutative property, what is the meaning? These are the definitions of commutative property. In my previous video, I have been able to explain the closure property. But now, today, we are talking about the commutative property in binary operation. And it said, given a non-empty set X, which is closed under a binary operation, if for all A, B elements of X, A operation B is equal to B operation A, then the binary operation is said to be commutative. So what I just tried to explain that if A operation B is equal to B operation A, but so many people find it difficult in my comment sections that they did not understand when a number set given a non-empty set. When we talk about non-empty set, it is the set that contains variables. It is the set that have numbers on it. So it is not an empty set that X, it is not an empty set like this. So it is not an empty, it contains value. So let's have a very good example that explains commutative property. It said, example, an operation is defined on the set of real numbers, so which is R, by A operation B is equal to A plus B plus 3AB. For all A, B element of R is the operation commutative. Now, this is how to determine maybe it is commutative or not. How do you do that? Solution. Now, we have been defined the operation to be A plus B plus 3AB. Now, anytime we now try to change this variable, for example, we said B to operate A. To operate A will give us B plus A plus 3BA. And recall that A plus B plus 3AB is equal to B plus A plus 3BA. Good. So now, if therefore this can be equal to this, it shows that A operation B is equal to B operation A. Therefore is commutative. Therefore, the operation is commutative. So that is the meaning of commutative. Now, in practical stage of explanation of this, there's a way we can be able to explain in practical way. How do you explain it in practical form? Like, to explain this in practical form, for example, I have like 2 operation 3, let's say we are represented by 2 operation 3. We have 2 plus 3 onto 2 times 3, to give us 5 plus, this is 6. 3 times 6, we have 18, which is equal to 23. So let's try to interchange it again to have 3 operation 2, which is equal to 3 plus 2 plus 3 onto 3 times 2. So which we have 5 plus 18, which also gives us 23. So this is the practical analysis explanations of the example we give in this form, that 2 operation 3 can be 2 plus 3 to multiply this, and 3 operation 2, both of them give us 23, as this gives us A plus B plus 3AB plus BA plus 3BA. So now, this is how to identify maybe an operation is commutative or not. So therefore, let's try to have another good example, another example that can give us the meaning of commutative better. So let's try to solve example 2. So we're in example 2. An operation is defined on the set of real numbers by x operation y is equal to x minus y plus xy for all xy is an element of real number. Is the operation, this operation commutative? This is a very reasonable question. And how do we now determine maybe it is commutative? Now let's write it out. Solution. Now we were being defined an operation to be this. This is an operation. It's defined to us that it is x minus y plus xy. And recall, it is an operation that's defined on the set of real numbers. So now, if this is x operation y, let's try to interchange this to have y operation x, which will give us y minus x plus yx. Telling us that from these equations, we're able to realize one fact that x minus y cannot be equal to y minus x. But let's try to have a practical ways of explaining this. Let's assume we have a real number like 2 operation 3. From our definition here, 2 operation 3 will be 2 minus 3 plus 2 times 3, which will give us minus 1 plus 6, which is plus 5. So let's try to define the same operation on 3 operation 2, which is 3 minus 2 plus 3 times 2. So therefore, we have a 1 plus 6, which will give us a 7. So, but recall that 5 is not equal to 7. Now, telling us that 2 operation 3, it is not equal to 3 operation 2. Therefore, since the operations are not equal, it's telling us that the operation, it is not commutative. The operation this is not commutative. So that is just the answer for this, because since 6 it is not equal to 7, it's telling us that since 5 is not equal to 7, it's then telling us that 2 operation 3, it is not equal to 3 operation 2. So therefore, the operation is not commutative. So I also want you to help me to solve this as classwork, and make sure you send the reactions to me in the comment section. You tell me your answer for me to know maybe you are getting it or not, and send me the message in the comment section. So this is a classwork, and the classwork is an operation is defined on the set of real number by A operation B is equal to 2A minus 1 divided by 2 plus B. For all AB, element of R, is the operation commutative. So you help me to prove it in a proper way, as in the numerical ways, and you prove it in alphabetical way. So we're able to know maybe it is commutative or not. So don't forget to subscribe and share this video. This class, if you're able to see that what we are doing is highly good and normal, help us to share this video. Help us to share it to the proper place, and send your answers to the comment section so I'm able to react on it. So thanks for watching.